Well, I enjoyed this game when I was a kid, but in 1996, when this 64-bit of this game has launched, it was executing around 100 million number of calculations in every second. Similarly, the game Minecraft was taking around 100 billion number of calculations in every second. And recently, you will not believe the game like Cyberpunk can take 37 trillion number of calculations in a second. But how do you think it is possible? If we take an example of AI models, the AI models having billions and billions of parameters also execute very fast. And all these are possible because of NVIDIA's GPU. So welcome to my channel, Bionic Algorithms, and today we will be talking about the GPUs. Okay, let's try to understand the complexity of calculations happening in a GPU. Imagine you are doing a multiplication of big number in every second. Now the similar kind of multiplication is done by all the people in this earth. Now imagine that we have 4,000 earth and all the people in those earth are doing the similar kind of calculation in every second. To do this kind of calculation, we need a GPU. And GPU is the hardware which takes all these calculations and process it in every second. Isn't it a very big number? But why it's not possible to do it in CPU? For that, we need to understand the difference between a GPU and a CPU. As I have mentioned before, GPU is nothing but graphical processing unit. It means all the graphics related processing can happen inside a GPU. But CPU is central processing unit. All the other kinds of calculations, including certain graphical calculations, happen in CPU. GPUs are something which can take or which is useful when we have to do a lot of calculations at the same time. Just like we are doing calculation in a convolution neural network model, which is an AI model. As an example, while training a ResNet model, you might have to do a lot of matrix multiplication at the same time. That's why when we run any kind of machine learning model, we make the use of GPUs. At the same time, when we run any application or operating system, that time we need CPU. So without CPU, we cannot run any application or any operating system. But without GPU, we definitely can run operating system and applications. It's not necessary that the laptop or the PC or the mobile phone what you have is having a GPU integrated in it. But if it does have a GPU, games or the video processing power of that specific device will go up. Now to understand this concept a little bit easier, let me give you one example. Imagine a ship shipping lot of containers from point A to point B. And all the containers are having some of the materials inside it. If we think in the perspective of cost, if a ship can carry 100 containers at the same time, but it is only carrying 10, then the transport cost rise. So in this specific case, optimizing the load is the key to reduce the expense. And this is exactly what GPU is doing. It is trying to process lot of data and try to get us the output. But in other hand, if we talk about CPUs, it is like aeroplane. It takes certain amount of data, do the processing from point A to point B and point B to point C. It means we can create those applications, we can run those applications in a sequence so that every task will be queued inside. And once the first priority task is executed, the second priority task will run. Why this is happening like this? Because a GPU can have almost 10,000 cores in it, which helps us doing all the computation parallelly. But at the same time, the CPU is having only 24 cores, which can do the calculation for us. Now, what are the hardwares inside GPU which helps us perform this task faster? So there are primarily three components in GPU. The first one is a CUDA core, the second one is a Tensor core, and the third one is a ray tracing core. Let's talk about the Tensor core first. So these tensor cores are responsible of doing any kind of matrix multiplication and addition. If you know the algorithm of transformers based on what LLMs has been built, and if you know the concept of attention, you can imagine the number of matrix multiplication what we are doing inside. Now, also another example of algorithm is any kind of computer vision algorithm where we try to convolute a kernel over all the images. Now, these kernels and the images are nothing but pixels, and those are considered as matrix. So when we do this kind of model, when we run or train this kind of model, the usage of GPU is going to be very high, and the availability of GPU can make your model run faster as compared to running it in a CPU. Now come to the CUDA core. So these CUDA cores are responsible for doing all kind of mathematical operation, arithmetic operation like multiplication, addition, division. It's just like a calculator. Now the third core is basically ray tracing cores. So these ray tracing cores are responsible of running all the ray tracing algorithms inside a GPU. And combining all these three cores, the GPU performs very fast for us and do all the video processing. Now, if we talk about the number of cores, then in a single GPU, we can have 10,752 number of CUDA cores. And in the same GPU, we will have 336 tensor cores, and we will have 84 ray tracing cores in a single GPU. If all these GPUs are having constant number of cores, then why do we have different varieties and different price range of GPU? These are happening because of manufacturing error. So you might have heard about the GPU NVIDIA RTX 3080 Ti and NVIDIA RTX 3080. Also, you might have heard about NVIDIA RTX 3090 Ti and NVIDIA RTX 3090. So the underlying chipset behind all these GPUs are same, which is a GA102 chipset. But there is a few difference inside those GPUs. When doing the production, because of dust particles or because of any other issues, there can be defective areas inside a GPU. Because of those defective areas, the whole GPU get wasted, and it's a waste of money and waste of production as well. So after a few research, the NVIDIA engineers have found out a very good technique of isolating those defective GPU and making them useful based on the defective number of areas in the GPU. The naming convention has happened. Like NVIDIA 3090 Ti will have 10,752 number of CUDA cores with no defects, but NVIDIA 3090 will have only 10,496 number of CUDA cores. Similarly, NVIDIA 3080 Ti will have 10,240 number of CUDA cores, but NVIDIA 3080 is going to have 8,704 number of CUDA cores. But the question still arises, why NVIDIA is one of the leading company to create GPU in this time, and why NVIDIA's GPU is used so widely. So before 2010, we didn't have much data and much compute with us to do any kind of AI innovations. But after that, when people started getting data and started developing different kinds of model, NVIDIA has tuned their GPU in such a way that those models can run actually very fast as compared to a CPU. So NVIDIA started creating this dependency on the AI developers, and once the AI developers started using it, they started building different applications surrounding to NVIDIA. Just like we have lot of application and lot of apps running in Android as compared to a Windows operating system, if you remember the Windows Lumia phone. And on top of it, in 2025, the models like transformers, the models like ResNet, and the new models like LLM are taking the world by taking lots and lots of parameters inside. And these parameters are nothing but a matrix when they try to get trained inside a GPU. When GPUs are training this kind of matrix, as we know, it can process way faster than a CPU. People started using this GPU to do those computation. On top of that, NVIDIA has got a lot of products related to AI, and which is unbeatable at this point in time. Hence, NVIDIA has created this ecosystem of AI, and we are dependent on NVIDIA. Well, that's a lot of information about GPU for today. But if you learned something, then do subscribe to my channel Bionic Algorithm, and do like and share as well. Thanks for watching.